With ControlNet for Flux and SDXL, you can easily transfer compositions from one image to another. Sure, there are other use cases like ControlNet for inpainting, which I covered in this video. A particular challenge is finding the best parameters, which works really well with the XY plot. One thing I haven't found on the net is XY plot in ComfyUI with ControlNet Parameters, especially for Flux. In this video I'll show you how to do that along with installing ControlNet, including UnionPro for Flux and UnionProMax for SDXL, and of course I'll show you ComfyUI Workflows and how to use them. If you haven't installed ComfyUI yet, watch this video. Let's get started. So before we start with the very first workflow, let's check if you have already installed all required nodes. By the way, this is the version of my ComfyUI and of my manager. If you have older versions, it might be a good idea to update your Comfy. For the workflows, you will require at least the following custom nodes. So you can simply install those missing nodes or just drop a workflow and press install missing custom nodes. I've shown in the linked video about inpainting how to install the ComfyUI manager and how to install missing custom nodes in case you drop a workflow and have some nodes being colored in red. We require two ControlNet files. From Xinzia, we require the ControlNet Union SDXL 1.0. In fact, it's the Save Tenses file with the ProMax. As usual on Hugging Face, here is the download button. The second file we require is from Checker Labs. The Flux.1 Dev ControlNet Union-Pro is this Save Tenses file, can be downloaded by pressing this button. After the download, you put these files into your ComfyUI in Models, ControlNet. You can put both files here, but for better organization I would suggest using the subfolders. So in the SDXL subfolder I've put the ProMax Save Tenses file. And in the Flux subfolder there goes the Flux UnionPro ControlNet Diffusion PyTorch model Save Tenses. As you can see, I have renamed the file in order to better recognize it. So back to Comfy, you can just press the refresh button and then both models will be found. In the following I will show you workflows for both SDXL and Flux. And if you want to see more videos like this, press the subscribe button. Let's start with the first workflow. This is for SDXL and as usual I have colored several nodes in green. These are the nodes with those parameters you might want to modify. So once the model is loaded, I've chosen the XL version of DreamShaper. Then the prompt and negative prompt are used. And here we have the ControlNet. It's exactly the file we have downloaded before. Here you can set the strength, so the influence of the ControlNet. And as usual, all information is passed to the case sampler. The case sampler is the main node, so doing most of the work, in fact doing all the steps for image generation. Additionally, we need an image for the input. Some people use simple load image nodes, but I prefer this one because it has some options like resizing the image if required. Moreover, the output of this load and resize image node has the width and the height, and so I can simply pass this to the empty latent image and it's not required to additionally enter, well, width and height here. The image is passed to the pre-processing area. This pre-processing node doesn't have many parameters. It's mainly the resolution and the kind of preprocessor, but it's very flexible because you can try different preprocessors without exchanging this node. Not all of these preprocessors are supported by a ControlNet. you can simply check the Hugging Face model card of the related ControlNet, and there is a description of all those preprocessors and the functions of the ControlNet you might want to use. Some of the most important preprocessors you might want to use, well, that's depth anything, that's Kenny or Kenny Edge preprocessor, and of course the OpenPose preprocessor. But feel free to try some more preprocessors which are included in the ControlNet model. This is the preview area of the preprocessor. Here you can simply check if the preprocessor is working as expected. And here a first hint: if you just want to check the result of the preprocessing without generating any images, select the Apply ControlNet node and press Ctrl M. This disables the Apply ControlNet node, so the workflow will stop at this position. And if we just queue the workflow, then you can see the result of the preprocessor. So that's depth. This is Kenny. And here we have OpenPose. Pressing Ctrl N enables the node. Finally, the case sampler will generate the image, and it will be decoded in a human readable pixel-based image. And here we have the result. The Save Image node makes sure that, well, the image is saved and you can find it later in the output folder. Let's switch back to depth. One more hint: if you simply double click into the canvas and type the word preprocessor, then you can find the preprocessor we are already using, as well as some more specialized preprocessing nodes, like for OpenPose, like for Kenny. And this has the advantage to set additional parameters, like a low and a high threshold. If you want to know more about this, check my video about ControlNet for SDXL. By the way, you can find all links in the description, and you can download all workflows from my Patreon page. You don't have to pay anything, it's free. So let's give it a try. The result is good, the composition is same. The woman and the background, well, are completely different. So how to change this workflow in order to support Flux? First of all, different model loaders are required. In this tutorial we will use the FLUX SCHNELL model. Current ControlNets are for FLUX DEV, but usually they work with FLUX SCHNELL in the same way. I'm using the GGUF versions of the Flux models. If you don't know how this works, please watch this video. And if you don't want to use the GGUF version, just use this node with the original model. For the ControlNet, a different node is required. most probably the strength of 0.6 will work here too. One thing I didn't know before was that we require a different empty latent image. This empty SD3 latent image includes more channels, and it seems that Flux requires these additional channels, so usually the empty latent image without SD3 will not work, or at least result in some errors. We have to add the entry points. The case sampler will not generate good results with these parameters, so we have to modify the parameters in order to fit the Schnell model. 4 steps. CFG1, but CFG shouldn't have any influence anyhow. Sampler is usually Euler, and the scheduler normal. Or simple, but normal is a safe choice. Flux doesn't use negative prompts, so the noise usually should stay at 1.0. So we don't require a negative prompt for Flux. And there is some special regarding the clip text encode for Flux. I will show you in a few seconds. Oh, by the way, what I've nearly forgotten is we have to load the correct ControlNet model. This time it's the one for Flux, it's the UnionPro ControlNet model. As you can see, the workflow is very similar to the one for SDXL, and you can use the preprocessors in the same way as I've shown for SDXL. Let's give it a try. So this worked too, and we have the same composition. Now it's a male, and of course the background is different. Now a small modification regarding the clip text encoder. Most people think it doesn't matter whether you choose this standard clip text encoder or the Flux version. But that is simply not true. So if we generate again after pasting the prompt into the T5 area, the result will be slightly different. So the result is a bit different, and how to say, well, now these balls are on fire. And I think even the fingers look a bit better. But decide yourself which clip text encoder node you prefer. Well, but how to know which are the best parameters for such a workflow? Which are the best number of steps, the best scheduler, or even the, well, best strengths for this ControlNet? The most efficient way to gather this information is to create an XY plot. For sure you have seen it several times or even used it yourself, but for me, especially for Flux, it wasn't too easy to find a suitable solution. Especially a solution which allows to modify and visualize the parameters of the ControlNet. At this point we require the tiny Terra nodes we have installed in the beginning of this video. Especially the tiny case sampler. This solution for the XY plot is that beautiful because we simply have to exchange the case sampler by the tiny case sampler, add 2 more nodes, and well, that's all. We don't have to change the whole workflow or exchange additional nodes. No, that's not required, so this solution is very simple and applied very fast. Let's quickly copy the parameters. I think we require the VAE. And we need a new save image. This is for the result of the XY plot. By the way, make sure not to have this save image at the default size. Simply enlarge it a suitable amount. I got some errors when I haven't done this. That was related to the font size being 0 for a very, well, small output image. And here we use the output plot image. What's still missing is the information for the TinyK sampler, which parameters to choose. This information is passed by using the advanced XY plot node. As you can see, we have even 3 areas. This is for X, Y and Z. You could even add a third parameter. It would result in creating several of these XY plots, in fact one for each Z. I usually set the grid spacing to 10. And here we have to enter values and labels for X and for Y. Let's simply connect the node. And now we can start entering values. If you left click into this area, you get this menu. First of all, for each entry on the X line, we need a label. Then we have to think about what we want to concentrate on. And what about checking different schedulers? The schedulers are in the TinyK sampler node. It has the number 70. So you can use these menus and submenus, but alternatively you could simply type in the text. You can see the ID of each node at the upper right corner. If you cannot see the IDs, go to the ComfyUI manager. And I've selected batch ID nickname, hide built-in. So TinyK sampler, scheduler, normal. Now we add another label. As you can see, it's number 2 now. And again, TinyK sampler, scheduler, and yeah, Keras is a good idea. If this looks quite complicated to you, please consider the following. For each label, so each label is like an entry, in this case for X, you could enter even 2 or 3 values, not just 1. So you could, additional to the scheduler, change the sampler from Euler to Hoyne, for example. That would be possible. Second advantage is you can use the XY plot with every node in your workflow and each parameter. And last but not least, this is true for the ControlNet. I haven't found another way using XY plot with Flux and ControlNet parameters. So let's add some more. Well, and of course I want to demonstrate the Y value for the ControlNet. We'll change the value later. I think 5 values are good enough. So let's choose 04, 05, 06, 7 and 8. We could add even some more parameters, for example to zplot, but for demonstration purpose I think these two are good enough. So for X we have the schedulers. DDIM uniform didn't work that well, and obviously the strength of the ControlNet has some influence. Side note, if you use DEV instead of SCHNELL, then you might want to XY plot the guidance. The workflow for SDXL is nearly same, so I won't modify it in this video, I'll just drag and drop. Again we have the normal apply ControlNet for SDXL and the usual empty latent image without SD3. Tiny K-sampler and the advanced XY plot, well, all that works same as for Flux. So let's choose a different pair of parameters for SDXL. What about using different checkpoints? In contrast to Flux, the CFG has lots of influence. So let's choose this one as the second parameter. We'll change the values later. In fact, it might be even more easy to just copy the text of an entry and paste it several times. And just modify the values. Well, it might be even faster in a text editor and just copy and paste. So here I've set the CFG from 1 to 9 in 5 values. Usually you would choose smaller steps. Let's have a look at the result. The prompt is obviously wrong. And we have to add the negative prompt. Now we can start the generation. So let's have a look. Obviously the models have a big influence on the generated image. We have DreamShaper, Juggernaut, Run Diffusion and Think Diffusion XL. And the higher the CFG, the more additional details we find in the images. There's nearly no limit regarding the parameters you can visualize. Standard choices are, for example, steps and of course the seed. But as we talk about ControlNet, the special parameters for the ControlNets are a good choice too. So for example, in case of using Kenny, what about choosing low or high thresholds? Generating XY plots can take a lot of time. Flux with ControlNet in particular can take several minutes per image, especially the very first generation with new settings. The following ComfyUI runtime parameters have proven useful on my PC, but only in the context of Flux with ControlNet. Try it yourself, maybe it will help. Which parameter combinations do you find most useful with XYplot? Please write in the comments. And if you enjoyed the video, please leave a like.